Lesson 27, I will compare fractions greater than 1 by creating common numerators or denominators. So in lesson 26, we compared fractions that were greater than 1. And we compared them using benchmarked fractions on a number line. We're going to continue to compare fractions greater than 1. Remember, when I say fractions greater than 1, I'm referring to mixed numbers, like 2 1/2. I'm also referring to improper fractions like 7/3, where the numerator is greater than the denominator. Today we're going to compare these fractions, but instead of using benchmark fractions and number line, we're going to be creating common numerators or denominators. And we have used this strategy before, but we've never used it before with mixed numbers and improper fractions. We've used it with just fractions that were like this, just regular fractions. So remember, when I create a common numerator, that means that the numerators or the number on top is the same. Or I create a common denominator, which means the number on the bottom is the same, because that makes comparing the fractions a lot simpler. All right, so we are going to do one problem in our math journal today. So I want you to go ahead and get out your math journal. I want you to write today's date, lesson 27, compare fractions greater than 1. Okay, so we're going to begin today by comparing these two fractions. We're going to compare these two mixed numbers, 3 3/8 and 3 3/4. So when you compare fractions like this, another strategy is we can find common denominators. Now, these actually already have common numerators, but we're going to go ahead and find a common denominator by looking at 8ths and 4ths. Because the whole numbers are the same, we basically can just compare the fractions. So even though it's important that this has 3 wholes and this has 3 wholes, because they're the same, it does nothing for us in comparing these two fractions, so we're just going to look at the fractions. So, in your math journal, I want you to show me a tape diagram that illustrates 3/8 and a tape diagram that illustrates 3/4. So remember, we're going to start with two tape diagrams, and they really need to be as similar in size as you can make them. If you're comparing two fractions, your wholes have to be the same. Just like it's half of a mini candy bar is nowhere near the same as half as a king size candy bar. So if you're going to compare fractions, your wholes need to be the same. So let's start by making 3/8. So I'm going to divide this. I like to always start with halves and then fourths. This helps me to keep my sizes pretty even. And then I'm going to take my fourths and divide them in halves so that I have 8 parts. Okay, so this is 8ths. I'm going to go ahead and use my highlighter here in shade 3 so that we can still see where I divided this. All right, so now I've got 3 out of 8. All right, so on the one down here on the bottom, I'm going to divide this into fourths. So I'm going to start with halves and then fourths. And again, I'm going to shade 3. Okay, so this is 3 out of 4. This is 3 out of 8. Now, if I want to have common denominators, the easiest way for me to do this would be to decompose these fourths into eighths. Remember how we do that? And it's important that you go ahead and use this dotted line when you're drawing your own so that you can tell the difference between where you decomposed it and where you did not decompose it. Okay, so now by using the dotted lines, it's pretty obvious to see that these originally was 3/4 and now it is eighths. And you can see here that instead of 3 out of 4, now I have 6 out of 8. So 3/4 is equivalent to 6/8. So if I wanted to compare 3 3/8 and 3 3/4, which is the same thing as 3 6/8, well, if I have 6/8 instead of 3/8, it's obvious that this is going to be less than. So you can see here that my strategy here was to find a common denominator because it's easier to compare when your units are the same. All right, so we're going to do some more of this today in our problem set. So I want you to go ahead and get your problem set out, and I want you to write your name at the top. And we're going to begin by drawing a tape diagram to model each comparison, just like we did in the last problem in our math journal. All right, so for A, it says, draw a tape diagram to model each comparison. Use greater than, less than, or equal to compare. So you'll notice that our whole numbers are the same. If our whole numbers were not the same, there would be no point in drawing a tape diagram. We wouldn't need to. We would be able to go ahead and compare these without the tape diagram. All right, so again, when you make your tape diagram, try your best to try to make them equal. All right, so now we're going to start with 2/3. So I'm going to divide this into thirds. And then this one's going to be sixes. So I'm going to divide this one into thirds. And then I'm going to divide it in half. So that's going to make sixes. All right, now I'm going to go back and I'm going to shade. All right, so I've got 2 out of 3. And I've got 5 out of 6. All right, now I want to find a common denominator. So the easiest way to do this would be to take these thirds and to decompose them into sixes. So I'm going to use my dotted lines here so that I can tell the difference. And look at what happens when I take these thirds and I decompose them into 2 parts. So now I have doubled the amount. So instead of 2 out of 3, now I have 4 out of 6. So 3 and 2/3 is the same thing as 3 and 4 sixes. So if I've got 3 and 4 sixes and I have 3 and 5 sixes, obviously this is going to be 1 6 less than 3 and 5 sixes. All right, so let's try this one. All right, so I'm going to, my whole numbers are the same, so I'm going to go ahead and model using a tape diagram here. I'm going to start by dividing this into 5 parts. So I've got 1, 2, 3, 4 lines. Makes me have 5 parts. Now for this one, I'm going to divide this into tenths. So I'm going to go ahead and start with fifths, and then I'm going to decompose each fifth in half so that I have 10 parts. Okay, now let's come back up here and let's shade. This is 2 out of 5. And I'm going to shade 6 out of 10. So 2, 3, 4, 5, 6. Okay, so remember my whole strategy here is to find common denominators. So right now this is 3 and 2/5, and this is 3 and 6/10. Well, if I want these to be tenths, they would be a lot easier to compare. So I'm going to come over here and I'm going to decompose these tenths, or these fifths actually, into tenths. So now I've got 1, 2, 3, 4 out of 10. So 3 and 2/5 is the same thing as 3 and 4/10. So if I'm comparing 3 and 4/10 to 3 and 6/10, this would be less than, because this is 2/10 less than the other. All right, so now let's take a look at 4 and 3/6 and 4 and 1/3. So again, our whole numbers are the same, so we're pretty much just ignoring those when we compare, and we're just looking at the fraction. Okay, so why don't you go ahead and pause the video and see if you can't show me how you can make 3/6 and 1/3 have a common denominator. So go ahead and pause the video and do as much of it as you can, and then come back. Okay, so hopefully you started by taking the first tape diagram and dividing it into 6 parts, and then the second tape diagram and divide it into 3 parts. All right, so we're going to shade this, and we're going to show 3 out of 6 and 1 out of 3. So remember, I'm trying to get a common denominator. So the easiest way to go from 4 and 3/6 and 4 and 1/3 to have a common denominator would be to decompose these thirds so that I would have sixes. So now instead of having 1 out of 3, I have 4 and 2 out of 6. So this is 2 sixes. So if I'm comparing 4 and 3/6 and 4 and 2/6, well, 4 and 3/6 is going to be 1 6 greater than 4 and 2/6. All right, so this is going to be the last one. Before I can do this one, I'm going to have to decompose this mixed number, or this improper fraction, to a mixed number. So I have to think about my multiplication facts for a minute and count by 4. So I've got 4, 8, 12, 16, 20. So 16 fourths and 3/4. So this will be 4, 4/4. So that would be 4 and 3/4. So you can see here that I've got two, my whole numbers are the same. So I'm just going to compare those fractions. So I'm going to draw a tape diagram to illustrate 5/8 and a tape diagram to illustrate 3/4. Okay, so let's start here with 5/8. So I'm going to take this and divide this into fourths. And then divide the fourths into eighths. And then I'm going to divide this one into fourths. I'm going to divide it in half. And then divide my halves into fourths. All right, so let's come back up here and shade. So now I've got 5 out of 8. 1, 2, 3, 4, 5 out of 8. And over here I've got 3 out of 4. Okay, so I have eighths and I have fourths. So if I want to have a common denominator, the easiest way would be to double these fourths by decomposing them into eighths. So I'm just going to take each of these fourths and decompose it into two parts. So now I'm comparing 5 out of 8 to 1, 2, 3, 4, 5, 6 out of 8. So 4 and 3/4 is the same as 4 and 6/8. So if I'm comparing 5/8 to 6/8, 5/8 would be less than 6/8. It's a whole eighth less than. All right, so now we're going to go back to a strategy that we used several lessons ago. We're going to use an area model to make like units. And the reason why we're using an area model is because if I drew a tape diagram that illustrated fifths, and I drew a tape diagram that illustrated sevenths, I could not decompose fifths into sevenths or sevenths into fifths. So we have to go back to this area model strategy. All right, so our area model is going to look pretty squarish actually. Remember, an area model is different than a tape diagram. Okay, and in the first one, I'm going to try to make fifths. Now before I do this, I need to come up here and make this into a mixed fraction. So I've got to think about my 7 facts. And I know that 7 times 2 is 14. So I can do 14 sevenths. And that's going to leave 4 sevenths left over. So 14 sevenths is 7 sevenths twice. So that's 2 and 4 sevenths. So I'm going to be modeling here 3/5 and 4 sevenths because my my whole numbers are the same. So I'm just going to go ahead and just look at the fractions. So now when I divide this area model, remember that when you're doing this strategy to find common units, you have to do one of them vertically like this. So I'm going to divide the fifths vertically by drawing 4 lines vertically. And then the other one has to be horizontally. So I'm going to draw 6 lines horizontally to make this into sevenths. So that is 3, 4, 5, 6. Now I'm going to go back and shade. And when you shade, you need to make sure that you're doing this in a way that you can still see the lines. The easiest way for me to do this is to use a highlighter. You can use your pencil, just shade really lightly so that you can still see the lines. All right, so that's 3 out of 5. And then this one I'm going to do 4 out of 7. Okay, so I don't have common denominators, but here's how you get your common denominators. You're going to go back and you're going to draw 7 lines horizontally, or make this into sevenths horizontally, and make this one into fifths vertically. So I'm going to match the lines over here. So I'm going to draw 6 lines horizontally. So I've got 1, 2, 3, 4, 5, 6, 7. So now I divide it into sevens this way, and I'm going to divide it into fifths vertically. So now I have 7 by 5. So this is now 30/5. I've got 7, 7, and 7, which is 21 30/5. And now I've got 5 by 7 over here. So this is also 30/5. So I've got 5, 5, 5, 5, which is 20 35ths. So I've got 21 35ths and 20 35ths. So 2 and 3/5 is the same as 2 and 21 35ths. 2 and 4/7 is the same as 2 and 20 35ths. So this is going to be 1/35 less than this. So 2 and 3/5 is actually greater than 2 and 4/7. All right, so now we're going to do one that has just a little bit smaller numbers, which will be a little bit easier. So now we're going to make two area models. So I've got 2 and 3/8 and 2 and 1/3. This time I'm going to use the line tool so it looks a little bit nicer. All right, so I'm going to divide this one into eighths. I'm going to start by doing half, and then I'm going to divide my halves in half. So I just doubled. So I went from 2 parts to 4 parts. Now I'm going to double it again by dividing my fourths in half. So I'm doubling fourths, which makes this eighths. Okay, so now I have 8 parts. Here, I'm going to do thirds, but remember I have to go the opposite direction. Okay, so now I'm going to go over here and I'm going to shade. I've got to shade 3 out of 8 to make this 3/8. And then I've got to shade 1 out of 3 to make this 1/3. So again, notice that I'm making sure that I can still see those lines. All right, now I'm going to come back and I'm going to divide these into thirds so that I can have a common denominator. That line just got crooked, but that's okay. All right, so now over here, I'm going to have to do the same thing over here that I did over here. So I'm going to start with halves. And then I'm going to double my halves to make fourths. And then I'm going to double my fourths to make eighths. So now in both of these, I have 8, 8, and 8, which is 24. So now I have 24ths here, and I have 24ths here. So this is 3, 6, 9 24ths, and here I have 8 24ths. Very, very close. So 2 and 3/8 is greater than 2 and 1/3, but it's only 1/24 greater, which is not a whole lot greater, is it? All right, now on the back, we get to compare each pair of fractions using greater than, less than, or equal to, using any strategy that we want. So what that means is you kind of need to look at each of these fractions and decide which strategy is going to be the most efficient. Now, it does say use a strategy. Your strategy cannot be just to put greater than, less than, or equal to, because it's too easy and tempting to just guess. So we're going to give some kind of explanation or some kind of proof that we actually work the problem out. So now if you take a look at this, so my whole numbers are the same. And you're also going to notice that my numerators are the same. So let's think about this for a minute. If I've got 3/4 and I've got 3/8. Well, if I divide something into 8 parts, my parts are going to get smaller than if I divide them into 4 parts. So 5 and 3/4 is greater than 5 and 3/8 because eighths are smaller than fourths. So right here, I'm just going to put common numerators to show that I looked at the numerators. That's how I solved this. Okay, for this one, I've got 5 and 2/5, and I've got 5 and 8/10. Well, because these are 5s and these are 10ths, it would be pretty easy to double these and say, okay, well, I'm going to double the fifths and make those 10ths, and I'm going to double the numerator and make those fourths. So 5 and 4/10 would be less than 5 and 8/10. Okay, so let's take this one. And the first thing I'm going to do is I'm going to change this improper fraction into a mixed number. So I know that I can do 25/5. That would be 5/5 5 times, and that's going to leave 2/5. So 27/5 is the same as 5 and 2/5. So now I've got the same whole number, and I've got 6/10 and 5/25. Again, this would be really easy to double the denominator and make this tenths, and double the numerator and make this fourths. So 5 and 6/10 is greater than 5 and 4/10, because 4/10 would be 2/10 less than 6/10. All right, so let's take a look at this one. So we've got 5 and 2/3, and we've got 5 and 9/15. All right, so I'm looking at this, and I have thirds and I have 15ths. They are related. I could take these 2/3, and what if I did this? What if I took the numerator and the denominator and I multiplied them times 5? That would give me 10/15. So now I'd have 5 and 10/15 to compare to 5 and 9/15. So which one would be greater, 10/15 or 9/15? 10/15, right? All right, now, both of these are improper fractions. So normally my first strategy would be to take these and make these into mixed numbers. However, what do you notice? They have a common numerator. So that means I can compare them pretty easy, because these are halves and these are thirds. Well, what do you know about halves compared to thirds? Which one's greater, halves or thirds? Well, halves are greater. So if I have 7 halves, that would be more than 7 thirds. So again, I'm just going to write common numerator, because I didn't have to do anything to this problem. All I had to do was compare the numerators. Okay, so I'm taking a look at this problem, and I'm going to go ahead and change these into mixed numbers. So I've got thirds here. So I know that 12 thirds actually is going to equal 4, because that's going to be 3/3 4 times, because 12 divided by 3 would be 4. So I really don't even have to use a number bond here. And then for 15/4, I'm looking at this and I'm thinking, well, I could do 16/4, that's too much. So I'm going to have to go back to 12/4, which is going to leave 3/4. So this is going to be 3 and 3/4. So now I've got the whole number 3 and I've got the whole number 4. Well, 4 is greater than 3. By showing my work, I don't have to give an explanation. All right, 4 more. So I've got 22/5 and 4 2/7. So I'm going to start by changing this into a mixed number. So I can say 20/5, and that would leave 2/5 left over. So this would be 4 and 2/5. Now I've got 4 and 2/5 and 4 and 2/7. So what do you notice about these two fractions? I have a common numerator. So what do we know about fifths compared to sevenths? Which one's greater, fifths or sevenths? Well, fifths are actually greater, because if you divide something into 5 parts, your parts are larger than if you actually divide them into 7. So since I have 2/5 and 2/7, I know fifths are greater than sevenths, so 4 and 2/5 is greater than 4 and 2/7. Okay, so let's take a look at this one. We're going to change this into a mixed number. So I can do 20/4 and 1/4. So 20 divided by 4 is 5, so that gives me 5 and 1/4 and 5 and 2/5. So I could find a common denominator, but 4 and 5 are not related. I would have to change both of those denominators. But look at the numerators, 1 and 2. What if I did this? What if I took my numerator and doubled it, and my denominator and doubled it? Now what do you notice? Now, instead of 5 and 1/4, I've got 5 and 2/8. And even though my denominators are not the same, what do you notice about my numerators? They are the same. So now, since I know that eighths are smaller than fifths, if I have 2/8, I have less than if I have 2/5 because fifths are larger than eighths. Okay, so let's take a look at this one. So let's go ahead and change this to a mixed number. So I can do 24/8 and 5/8. That's going to give me 3 and 5/8. And then over here, I'm going to do, let's see, I know 3, 6, 9. So I can do 9/3, and that's going to leave 2/3. So this is going to be 3 and 2/3. So my whole numbers are the same. My numerators aren't related. My denominators aren't related. So I'm thinking, I'm going to have to find a common denominator. So I've got 5/8 and I've got 2/3. So instead of using an area model, I'm going to take my numerator and my denominator of the eighths and I'm going to triple them like this. That's going to give me 15/24. And then for this one, I'm going to take my numerator and my denominator and I'm going to multiply these times 8. And look at what happens. Now I have a common denominator. So this is going to be 15/24, and this is going to be 16/24. So 3 and 2/3 is actually larger than 3 and 5/8, but they're very close. It's actually only 1/24 larger. Okay, so let's take a look at our last one. We have our whole numbers are the same, our numerators aren't related, our denominators are not related. So again, we're going to have to take 3/4 and 4/7 and find a common, I think we'll just find a common denominator. So I'm going to take my top fraction and I'm going to multiply it times 7. And that's going to give me 21/28. Now the reason why I chose 7 is because these are sevenths. So now I'm going to take my 4 and my 7 and I'm going to multiply these times 4 because these are fourths. And when I do that, I'm going to end up with a common denominator. So now I've got 21/28 and 16/28. So which one would be more? Well, 21 is greater than 16. So 3 and 3/4 would be greater than 3 and 4/7. So let me end this video by saying that we went through a lot of strategies today. And comparing these mixed numbers is not easy. It's not easy at all. So I want you to give yourself a break if this doesn't seem to come to you naturally. I want you to try to do your Excel slip the best that you can. I want you to try to use a strategy that makes the most sense to you. And I want you to look back at your problem set and see if you can find a problem that's similar to the one you're trying to work to see if you can't figure out how to solve it.